Alright, video 3. Example number 4. Determine the equation of the tangent to the curve y equals root x minus 1 at x equals 5 using limits. So again, we need to find the equation of the tangent to the curve y equals root x minus 1 at x equals 5 using limits. What we're going to do is take the limit as x approaches 0 of f at x plus h minus f at x all over h. And we're going to find the generic equation again. Now, I know a lot of you are saying, but Miss, why can't we sub in 5? The book already puts x for 5. Again, remember that it's okay if you only have to do the equation for 1 point. You can do that. But what happens if you have to do it for more than 1 point? It makes more sense to find the general slope of the equation, general equation of the slope of the tangent first before finding a specific value. So what do we have to do here? Well, if you remember from 1.1, you'll see that when we have a root minus another root, if we multiply the root plus that root, so a difference of squares, folks, we end up with no more roots. And why would we want to do such a silly thing like that? Well, right here, you'll notice our magic 1. This magic 1 will help us expand the numerator. And once we expand that numerator, we'll find something that can eliminate this ugly h. The whole goal behind this is to get rid of h. All right, here we go. And we find out that it's root x plus h minus 1 times root x plus h minus 1 is going to be x plus h minus 1. And minus the root times itself, it turns out to be just the value under the root sign, so x minus 1. On the bottom, you have h times that ugly thing over here. So we're going to multiply all of that. Once we do that, you take the numerator and you're going to expand it. And once you expand it, you get, oh, look, folks, just h. Wow, that's so cool, just h. On the bottom, we have h times that ugly thing in the brackets. We're just going to leave it. Now, why did we want to do something like that? Well, look, folks, look what happens to these two h's. H disappears, and you're left with 1 over that ugly thing inside the brackets. What do we do with that? What do we do with that? Well, folks, now we've eliminated the possibility of the denominator being 0. So we can actually plug in 0 for the h now, and it turns out that the value is going to be 1 over 2 root x minus 1. Why is that? Let's go back to the last question. Back over here. Now look over here. Over here. We're going to put 0 here. So it's going to be root x minus 1 plus root x minus 1. That's the denominator. You have 1 root x minus 1 plus 1 root x minus 1. Together, that gives us 2 root x minus 1. So cool. All right, once we do that, we have 1 over 2 root x minus 1. At x equals 5, m is equal to 1/4. That means we're going to plug in 5 into this x. 5 minus 1 is 4. Root 4 is 2. 2 times 2 is 4, so it's 1 over 4. We're going to sub m equals 1 over 4 and 5, 2. So the point 5, 2, where did that come from, folks? Let's look back on the other question so that we can come back to this. And we notice that x equals 5. Oops, sorry, 1 second. X equals 5 right up here. X equals 5. And we have the equation, so we plug in 5 minus 1. 5 minus 1 is 4. Square root of 4 is 2. So we go back to the next question, and last question, and we have this, okay? We have y minus y1, so we have the points right 5, 2, plugging that in, plugging in the slope into the equation, and we have y minus 2 equals 1/4 times x minus 5, and you end up, when you expand it, if you were to expand it, you have to multiply everything by 4, because no fraction fractions or decimals are allowed in standard form. So you have 4y minus 8 is equal to x minus 5. And you move everything to one side. So you have x minus 4y minus... I don't think it's plus 3. Let's just check our math. Oh, yeah, sorry. We're moving everything over to the other side. So this is going to move to this side. This minus 8 is going to move to this side. And you end up with x minus 4y plus 3 equals 0. And that's standard form. And most of the often, the standard form is the preferred answer that is expected for equations of a line unless it specifically says slope-intercept form. All right. Last page here. Example number 5. Determine the equation of the tangent to the curve y equals 1 over x plus 2 at the point -3, -1. So this time I give you the point using limits. So how are we going to do this? Well, up until now, I made you find the general equation. Let's do it specifically for this point at x equals 3. So limit as h approaches 0 of x plus h plus 2 minus 1 over x plus 2 all over h. We're actually going to sub in x equals -3. The reason I'm doing that, folks, is so that we can find just the specific one. We're looking at a fraction over a fraction. I don't know about you guys, but it starts to get really complicated. If we start plugging in the number and we have 2, we have an x and an h and trying to figure that out, I think, folks, it'll be a lot easier if we just sub in x equals -3. The idea here is that up until now, I'm forcing you to find the general equation of the slope of the tangent, but really, we don't need to do that. It's just something that's a good idea. Now we're going to find the value at x equals -3. So limit as h approaches 0 of 1 over h minus 1. Now, why is it h minus 1? Well, I plugged in a -3 here. -3 plus 2 gives us -1. So it's going to be h minus 1. Over here, it's going to be -3 plus 2, which is -1. 1 over -1 is -1. And negative makes positive, so it's plus 1 all over h. Now, what we're going to do is take the numerator and find a common denominator with just the numerator. So the numerator is going to have a common denominator of h minus 1. And then this 1 is h minus 1 over h minus 1. So it's going to be 1 plus h minus 1 all over h minus 1 divided by h. Now, change that division to multiplication. And you're going to see something magical appear. So up here, we have h. On the bottom, we have h minus 1. And that times it by 1 over h. So this h and this h both cancel each other out. And once they cancel, you end up with, oh, look, folks, limit as h approaches 0 of 1 over h minus 1. Now remember, what we did here is we don't have any more x's because we're now finding the general equation. We're only finding the slope of the tangent at this point, not the general equation. So this is going to give us the slope at x equals -3. Okay? So this is the slope at x equals -3. So this is the slope of the line at that particular point, slope of the tangent line. We're going to sub the slope and the point into the equation. Y minus y1 equals m times x minus x1. And it turns out that you end up having y equals -x minus 3 minus 1, which is minus 4. So y equals -x minus 4. Or, in standard form, you would end up having x plus y plus 4 equals 0. All right, so that's the last one. All right, just as a little funny, I found this the other day in my teacher calendar. And you can see here, and the teacher says, I had a nightmare in front of a class of ridiculous 18. And then the teacher over here, the line doesn't show up here, but this guy says, I'm living the life. Basically, I'm living the dream. And this is, in this particular teacher's case, it's a nightmare. In this particular teacher, it's the dream. Okay? It's just a funny little thing. So I'm living the dream, folks. I'm teaching you guys. Take care. We'll talk soon. Bye.